right. Well, obviously going through these questions will help. If your exam is, I'm guessing it's in the next couple days or day. Is that true?
Yeah.
Okay. I'll do what I can to help. Maybe I'll give you some other options for the exam towards the end. So, are you at ASU, U of A?
Yes, you.
ASU. Okay. Awesome. All right. So if you can see my screen, you'll see question 28, and we'll just work through this one for the time being. So 28 here, it's just asks you to find the derivative of the function. We're going to rewrite this using exponents. So instead of writing square root of x, write x to the 1/2 plus 9. It's over x to the 1/2. So the the best way to represent it is x to the minus 1/2, just moving this up to the top level there. This is a power rule derivative.
Yeah, this is the one rule that I understand.
Excellent. So then you already know that the answer is 1/2 x to the minus 1/2 plus 9x to the minus 3/2. Then you multiply by minus 1/2 there. Now WebAssign is really nice. It will actually accept this answer. If you wanted to, you could clean it up a little bit and make this like minus 9/2 x to the minus 3/2. But I would use the fraction exponents here. I would not try to like put it down into another form. Do you plan to enter these as we go? Is that important to you, or is it just doing as many problems as we can?
I'm just doing them, honestly.
Okay. I'm going to get back to 29 now. Is that seem right?
Yeah.
Okay. Let me snip that in. All right. Are you allowed to use a graphing calculator during the exam?
It's confusing. She says no, we're supposed to use a calculator that they provide for you, but then I took a quiz today and there's no calculator, so
Okay.
I don't
Well,
know.
because I was going to say you can graph this on a calculator and figure that out, but um, the notice how the red line it like this one goes to the right, this one goes to the right, up and to the right, up and to the right, down to the left, down to the left. We're going to get enough information to be able to do it without graphing it, but it is nice when you have that option there. The first thing you've got to do when you're finding the tangent line is to find the derivative. So do you have, so if you're comfortable here, this is obviously x plus x to the minus 1. The derivative is 1 minus 1 x to the minus 2 power, which is sometimes written as 1 minus 1 over x squared. You have to put that value of 4 in to get the slope. So when you put the value of 4 in, it's 1 over 4 squared, which is 1 minus 1 over 16. And that reduces to 15 over 16. That's your slope there. So notice how the slope is positive. That tells you that it could possibly be this one top right or top left because the slopes are positive. Is that okay? I mean, does that sound reasonable?
Yeah, so you just took the derivative, you plugged back in x, and then we got 1 minus 1 over 16. Okay. Yeah, that makes
Yes,
sense.
that makes sense. And that gets you down to 2 graphs at least. So it's, I mean, that helps. To find the equation though, you need, your instructor should have said something at some point, use point slope form.
Okay. Yeah.
This is the slope. And then you
Okay.
need the x and the y value. So the x value is 4. You get the y value from plugging 4 into this equation up here in the top left. So f of 4 is 4 plus 1 over 4. Yeah, it's 4 and 1/4, but it's going to be written as 17 over 4. So this becomes y minus 17 over 4 equals 15 over 6 x minus 4. So that's almost ready to be put into that box up there in the top right. You don't have to simplify. You can leave it as 15 over 6 x minus 4 plus 17 over 4. WebAssign will accept that.
Okay.
Now to figure out what graph it is, any questions on that? Now we can figure out what graph it is.
Okay, no, I get that. So that's what I would put. Yeah, okay, that's what I would put in there. And then, yeah, for the graph, like they look pretty similar. So how do I?
Yeah, so notice the one difference is that that one's below the x-axis on the left. Sorry, it's not. That one's below and that one's slightly above.
Okay.
So it comes down to the b value here.
Oh, okay.
And it looks like the b value is going to be negative because it's 15 over 6 times negative 4 plus 17 over 4. So that's negative 60 over 6, which is negative 10. So it ends up being less than 0. I mean, you don't have to do it perfectly to do it. Like I said, if you could graph it, it would, if you could have a calculator, you would see this right away. But that's everything on that one there.
Okay.
All right, I'm going to move to 30. Snipping this one in. All right. So the question says find all values where the tangent line of the graph is horizontal. This is another way of saying where is the derivative equal to 0.
Okay.
So we have to be able to take a derivative. So f of x is 5x minus 5x to the 1/2. And the derivative, you said you're pretty comfortable with power rule, is 5 minus 5/2 x to the minus 1/2. We have to set this equal to 0. So this is now like an algebra problem. So if the calculus is over, just getting comfortable with solving this now. So we're going to rewrite this as 5 minus 5 over 2 square root x equals 0. This is a more common way to solve this. Move this term to the other side by adding it. 5 equals 5 over 2 square root x. Then you can cross multiply here. So you get 10 square root x equals 5, just multiplying these and then these. Divide by 10, so you have the square root of x equals 5/2. I'm sorry, 5 over 10, which is 1/2. So the square root of x equals 1/2. To undo a square root, you're going to square both sides. So x equals 1/4.
Okay. Sorry, 1 second. I'm kind of slow.
So you have to take a derivative. You set the derivative equal to 0. That's what it means by horizontal. And then the rest is just algebra, moving things around and finding answers.
Okay. Wait, can you go back down to your work?
Yes, let me
And you took the
scroll down.
derivative, you set it equal to 0, and then we solved that algebraically.
Yes, I'm sorry, just a moment. Okay, so let me scroll down here. You take the derivative. That's this step. This is the derivative. This is the only calculus step
Okay.
that you have. And then you set derivative f prime of x equal to 0.
Okay, and then you got 5 equals 10 square root x, and then what did you? Is there anything past that?
So, you divide both sides by 10.
Okay, and then you
And
get
then
equals square root of x, and then okay, and then it becomes 1/4. Okay.
yes, and you square both sides and get 1/4.
Okay, that makes sense.
A lot of times WebAssign gives you an option to practice another. Oh yeah, it is in the top right. I mean, if you have the time, it would be great if you could do that. That would definitely help for that.
Okay.
All right, can we move to 31 now? Is that okay? Or 30? I guess 34 is the next one I'm seeing.
Yeah,
Okay.
34.
Yeah, 34. Let me snip that in. So 34, they give you a function and they ask for marginal cost, marginal revenue, and marginal profit. So the word marginal means derivative. That should have been made clear. So you need to find C prime, and that's for this first one here. The derivative is 5 for that one.
Yeah.
Marginal revenue, that's R prime. That's the derivative of this one on the right here. So that's 8 minus, bring the 2 down, 0.002x.
Okay. And then
Is that,
profit.
yeah, so profit, P prime is R prime minus C prime. So that's 5. I'm sorry, I got those backwards. It's 8 minus 0.002x minus 5. And then you want to simplify that to 3 minus 0.002x. So this is 5. This is the 8 minus 0.002x. 0.002x.
Okay, and then for final values of x, when the profit is 0, do you just set it equal to 0?
Yes, exactly. You set this last part equal to 0.
Okay.
So x ends up being 3 divided by 0.002. And if you got, I mean, you'd almost have to have a calculator for that. I mean, you could do it by hand, but I don't know.
I have a calculator on the test. I just don't know if it's going to be like my own or the computer. Yeah. So is it negative?
Positive, because you add I'm skipping some of the intermediate steps, and I don't need to do that. I'm sorry for, I shouldn't do that. And then you divide both sides by 0.002.
I see now. Yeah. Okay. Okay, we can move on.
Again, I'll just reiterate the nice thing here, and I mean, sometimes you got to take a class like this more than once to know this, is like the tests are just like these questions, just with different numbers.
Okay.
And I'm sure you figured out by now that the only thing that changes is the red number when you're doing these problems. So the it can be really helpful to to do these problems over and over again, because you're actually gonna get the same thing.
Yeah.
All right. So this time around, they give you they tell you that they will charge each student $1.10 per serving. So your revenue function is 1.10x, meaning like for every one you sell, you get $1.10 for each one.
You pulled that from the word problem.
Yes, but it's the same. It's going to be the same if you get this problem, because that number is not red.
Okay.
Interestingly enough. So R prime is the derivative of that. The derivative power rule is just 1.10. The profit, oh, they don't even ask you about. So P prime of x is R prime of x minus C prime of x. So we need to find C prime, even though it doesn't ask you for it. So C prime of x is the derivative of this up here that I've circled. It's 0.1 plus 0.004x, just using the power rule there.
Okay.
So P prime of x, I know I'm trying to get a lot in here, but it's taking that R prime 1.10, subtracting 0.1 plus 0.004x. So it equals 1 minus 0.004x. That's what goes in that box there. 1 minus 0.004x.
Okay, that's P prime.
Mm-hmm.
Okay.
Okay, so now there's a lot to do in this problem. You've got to find the revenue, the profit, marginal revenue, marginal profit. We probably should have done some of these first, because like revenue R of X, I don't even know where to put that. R of 200, because that's the 200 there, is 1.10 times 200. That's the revenue function. Is that clear?
Yeah.
Okay, so you get that number, you put in there. The profit, sometimes use PR for profit. The profit of 200 is your revenue, 1.10 times 200, minus your cost of 200. So your cost of 200 is 380, because I'm getting that from the top left here, plus 0.1 times 200 plus 0.002 times 200 squared. So that's a number.
Okay.
Marginal revenue, that's R prime. This is, I'm sorry, let me do this. This is R, this is PR or P, this is R prime, and this is P prime. So R prime of 200 is the derivative. The derivative is 1.10. It's always 1.10. So it doesn't matter whether it's 100, 200, 300, it's always 1.10. P prime, that's what we calculated here. So P prime of 200 is 1 minus 0.004 times 200, and that's a number.
Okay.
So now there's a bunch more to do on this. It says interpret the results. The approximate, I don't know what goes here.
Look.
Revenue,
What is this?
profit. It's 35.
Profit or loss?
Say that one more time.
Profit or loss?
Profit or loss. Okay, so that depends on this. Yeah, it's profit. And the number that goes here is your P prime.
Wait, what did that depend on?
This number down here, P prime, whatever we put in this one here.
Okay. Okay, so I got. Oh wait.
Normally I would do these calculations, but their numbers might be slightly different on the exam, but this should be like 8. This should be like 0.2, I think.
Yeah, so P prime, yeah, is 0.2, and then you would just put that in that box.
Mm-hmm. And then for C, it's asking about the marginal profit. So that's the derivative. Where is the derivative equal to 0? This one is asking, where is P prime equal to 0? Where is 1 minus 0.004x equal to 0? And you're solving for x. So it ends up being that x equals 1 divided by 0.004. I think that's like 25, 250, 2,500, 250. And then the same number goes here and here.
Okay. Okay, we can move on.
Okay. The next question. So that was 35. That was a lot there. I see 37 is the next one. Is that right?
Yeah.
Okay. A couple of them have the question numbers, problem numbers cut off. So
Yeah, those two that I cut off are 39 and 40, so
okay.
those are the last ones.
Great. All right. So this is asking you to find the derivative, and it does say to simplify. I mean, my experience is that WebAssign doesn't care, but you may. I mean, I don't know if I would trust it on a test. This is a quotient rule problem.
Okay.
I'm sure you've heard of that quotient rule. So it's when you have I use u over v for the quotient rule. And the derivative of this, I'm going to write it out symbolically. It's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. To do this problem on your own, you're going to have to decide, okay, I'm going to call the top u. In my case, I like the top to be u. And you have to find u prime. What is u prime? What is the derivative of this? Well, that's just 3.
Wait, so you're calling 3x plus 9 u?
That's right. And the derivative u prime is 3.
Okay, so u prime is 3. Okay, and then the bottom is v?
Mhm.
Okay.
Your book might use f over g, your instructor might use something else.
Okay.
This is it's a very useful way of doing it. So v is the bottom 4x minus 1. V prime is 4. So now it's a matter of, for your derivative, it's a matter of taking what's in this rectangle up here and substituting the numbers in, or substituting the quantities in. So for example, it's 4 is v, u prime is, I'm sorry, I wrote the wrong thing. V is 4x plus 1. I'm sorry, minus 1. Minus 1. And then u prime is 3 minus u, which is 3x plus 9, times v prime, which is 4, all over 4x minus 1 squared.
Okay, wait. Let me just like try to comprehend that. Okay, so you took v is 4, you put 4x minus 1 multiplied by 3. Okay, yeah.
U prime, so
So that makes sense.
you're pairing these up, diagonally pairing them up, and then I think WebAssign will accept this. I know it says to simplify, but I think it would accept that. The rest of this is about distributing and combining like terms. So like the top looks like 12x minus 3 when you distribute that in. This over here, it's 12x, but there's a negative, so minus 12x, 36, there's a negative, and the bottom stays the same. So the top becomes, those cancel, minus 39 over 4x minus 1 squared.
Okay. Okay. That makes sense. And then we can move on to 38.
Yes, let me get that here. Oh wow, this one's awful. uh, okay, you need not expand your answer, and what that means is do not simplify.
Okay.
Do not simplify. So this is a product rule question. So let me write out the product rule. Product rule is a u times v. And the words I think are more important here. It's the first times the derivative of the second plus the second times the derivative of the first. So in your problem, your first is this x to the 0.8 minus 4x minus 7. That's your u. And usually it's like what's in parentheses, what's in the top, what's in the bottom. Those are all possibilities.
Okay. So
we need to get u prime here.
okay.
So that's 0.8 x to the, and then when you subtract 1 here, you get minus 0.2 minus 4 for your derivative. V is x to the minus 1 power plus x to the minus 2 power. So v prime, using the power rule, is minus x to the minus 2 minus 2x to the minus 3. It's probably best if we put these all in parentheses.
Okay.
Now this is where like not simplifying matters, because you just have to pair these things up. You're pairing up u with v prime. You're pairing up this u with this v prime.
Okay.
So your derivative, your dy dx, is x to the 0.8 minus 4x minus 7 times, in parentheses, minus x to the minus 2, minus 2x to the minus 3, plus, that's this plus up here between them, and then you pair these other two together. 0.8 x to the minus 0.2 minus 4 x to the minus 1 plus x to the minus 2. I will share with you that most common mistakes here are just typing this incorrectly.
Okay.
So I would definitely want to double triple check whatever you can do for that.
Okay. So you're just distributing these.
I called it pairing. You're pairing these diagonally because u goes with v prime. This is u in top left. That's v prime, and then these go together.
Okay. Okay, that makes sense.
Okay. Can we move on to the next one?
Yeah.
Okay, great. You're definitely going to get a product rule and a quotient rule on your test. Just be good to work these out again on your own to be comfortable with it.
Okay.
So this one this one is a product rule. This first thing is your u, and the second one is your v. But I'm going to rewrite u. U is going to be 1 over 3.6x, and then plus 3.6x to the minus 1 power. And the reason is it's easier to do power rule when you have exponents like that. So u prime is 1 over 3.6 minus 3.6x to the minus 2. So I would leave it like this. I wouldn't try to make it simple because you're entering it into a computer. They don't care.
Yeah.
V prime is the derivative of this thing on the right, and it's just 2x. So again, it's probably best to put everything in parentheses, especially when you're entering it into WebAssign. It'll help like hold the answers.
Yeah.
So the derivative of uv is uv prime plus vu prime. You get a u with a v prime and a v with a u prime. So that looks like 1 over 3.6 x plus 3.6 x to the minus 1. In WebAssign, it's usually good to put the parentheses in first, times 2x plus, and then I'm going to grab this other one, 1 over 3.6 minus 3.6x to the minus 2 times x squared plus 1.
Okay. Okay, we can move on.
Right. So the next one here is, oh boy, quotient rule. Another quotient rule. Quotient rules are kind of the worst because they don't usually simplify nicely. I know it says not to simplify, but they're just a lot to write. But
Yeah.
pretending like you won't get one on tests is never a good strategy because you could get one. The u is it's going to be u over v. U is x squared plus 7x minus 1. U prime is then 2x plus 7. Your v is x squared plus 6x minus 1. Your v prime is 2x plus 6. Your derivative, again, it's bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. This should definitely be on your reference sheet for your exam.
Okay.
So your bottom here is x squared plus 6x minus 1 times 2x plus 7 minus, and then it's x squared plus 7x minus 1 times 2x plus 6 all over x squared plus 6x minus 1 squared. and you would enter it exactly that way. It says you need not expand your answer. That means don't simplify.
So I would enter that like into the answer box or my calc.
Yes. No,
Oh,
this is what goes into that box there.
okay.
It's a lot. I mean, it looks awful when you're doing it.
Yeah, that looks awful. Okay, so I guess that's everything that I was like had no idea about. I had other questions.
Sure. Yeah, let's see what else
Well,
would you like to work on?
I'll just go through here and take some more screenshots and then send them over to you. Okay, I sent them over to you. I might have put one that we already did in there. Oh, wait. Did we do 29? Yeah, we did 29. Oh, wait. Okay, starting with 11.
Sounds good.
My question on this was, one second, let me look at my notes. Because I got this one right. I just didn't know the explanation why. Like I plugged it in and I think I got 0 for the denominator. And so it was undefined, but I didn't know like what the explanation was. I just guessed. So I need to know like why does it say that the limit doesn't exist? Because it diverges. Like I don't know what that means.
Okay. Yeah. So the if I hate saying it this way but it's really the most important reason is if we had a graph of this, it would be very clear what's going on here. But you're right. When you put -3 in, you get x squared plus, well, sorry, you get the bottom becomes 0.
Yeah.
So this -3 from the left means, and I'll just give you a value, minus 3.00001.
Okay.
Okay, and that is what tells you that it goes to one of these other ones. Because what you'll see is when you put this value in, I'm sorry. Okay, I see what's going on. When you put this value in, you're going to get minus 3.0001 squared plus 5 over minus 0.00001. And what this means is this on the top is a positive number. This on the bottom is a really small negative number.
Okay.
And that's what goes to minus infinity.
Okay. So I have it on my calculator right here.
Yeah, Yeah, so what you should see from at -3 is that on the left it goes down like that.
Yeah.
I don't know what it does from the right. Actually, from the right I can tell it goes up.
Okay, so the limit does not exist because it diverges. What would it look like if it said the limit does not exist or does not exist because the function is not defined to the left or the right? Like, what does the defined part mean?
This one doesn't, it wouldn't apply, but it would be like these two here would be for something like absolute value x plus 3, because you can't go left of it, or a natural logarithm of x plus 3.
Oh, okay. Okay, that answers my question. We can move on.
All right, 13.
Yeah.
Okay.
For 13, I got the first part, but then, one sec.
I'm looking at this too. So you got the answer right for that.
I just don't know what the 2-year average rate of change. What does 2-year average rate of change mean?
2008 2030. I'm looking at this. I'm trying to make sense of it myself. The 2-year average rate of change would be like going from 0 to 2 and then 2 to 4. Um, the only thing I can say is that these tend to always be the same. I don't actually know why this is, why, I don't know what it means by increased in value, because the rate of change, the average rate of change would be like 2.07 minus 2.35 over 2 minus 0 for this first jump.
Yeah.
And then the second jump is 2 minus 2.07 over 2 minus 0. And I mean, this top one becomes negative 0.18. This one's negative 0.09. This is negative 0.035. So it is true that it increased in value, because even though they're both negative, the jump here this is a larger ARC than this top one.
Okay, so
It's like saying this way: 0.09 is less than minus 0.035. That's why it increased.
okay. So what I should have done is taken the average rate of change from 0 to 2 and 2 to 4 and compare
Yes.
them and see if they.
Yes. Yes. It looks like it works out if you go from 1 to 3 and 3 to 5 also.
Okay.
You get the same thing.
Okay. So take average rate of change on 2-year intervals. Okay, we can move on.
16 is the next one that I've got here.
Yeah. 16. I just don't know what instantaneous rate of change is, and so I got stuck on that.
The instantaneous rate of change is the derivative at a point. I'm trying to figure out what this one is asking for, but let's look at it in more detail. So you got part A correct. The average rate of change. So the f prime of 10 right here, the f prime of 10 is equal to 0 because it's got a horizontal slope of 0 there.
Okay.
So the average rate of change from 10 to 20, that's the slope here. This right here is the slope of this line.
Okay.
So it goes up 5, rises up 5, and over 10.
Yeah.
Which is why it's greater.
Yeah.
From minus 5 to 5, that's from here. Oops, I'm sorry. I grabbed the wrong place. From here to here, the slope, you're going up 15 and you're going right 10. So that's 3/2 or 1.5. Well, that's still greater. Wait, I'm not seeing that. -5 to 5.
Is
So
it
it says
correct?
it's,
Approximately equal to f of 0, or yeah, there's another attachment after
oh,
that.
okay. What it's saying, here's what it's saying is that this slope here is about the same as this slope here, because at f prime of 0, your tangent line, they're parallel. So it's a new point 0 instead of 10. 10 at 0, but at 0 it looks like it's got a tangent line like that, and this is the tangent, and this is the ARC, average rate of change. So
Okay.
that's why they're approximately equal.
Okay. And then there's more in that problem. Like
Oh, another screenshot. Okay.
this problem.
Over the interval 0 to 10. So we're looking now from 0 to 10. I guess I need to grab the graph again. That would be useful. So let me grab the graph, and then I guess I'll just have to talk through the problems to. So let me grab another picture of the graph. All right. So part C, it's asking about the interval 0 to 10, the instantaneous rate of change. So it's saying from here to here. See how the graph is going up and to the right? That means that the derivative is greater than 0. If it was going down and to the right, that means that the derivative is negative.
Okay.
So part D, this is part C. Part D is saying over the interval 0 to 20. So now we're going from 0 to 20. The instantaneous rate of change, like they're asking, well, what happens? Well, the derivative, the slope of the line here is positive. Then it's 0, but then it's positive again. So the derivative is oh, is this the graph of the derivative? Or is there a different graph for this?
That should be the same graph.
Decreasing then increasing. Was it the graph of the derivative? Okay. So okay. So what they're saying here is that the slope of this line, if I draw a bunch of tangent lines here, their slope's getting smaller and smaller. Then the slope of the tangent line gets greater and greater.
Okay.
And that's why it's decreasing and then increasing, because of those tangent lines.
Okay, so when I come to one of these questions on the test, my original approach was taking the average rate of change between those intervals and seeing if it was basically increasing or decreasing, which obviously doesn't get me the right answer. So
No.
what do I need to do differently? When I see a question like this, I don't know. I think I'm just confused on my strategy.
Okay. So average rate of change is slope, and then instantaneous is tangent line. So you've been doing that. The only thing you've got to modify here is to look for the tangent line.
Okay.
Do we have another lesson scheduled between now?
Tomorrow.
I'm sorry. Say that again.
It's tomorrow.
Tomorrow. Okay. We do have to stop here. I think with another lesson we can clear a lot of this up.
Okay.
I would encourage you though to work on the problems that we did again, to get those down, and then we can get some of those other ones down in more detail.
Okay.
Thanks so much for scheduling. I'll send you a PDF of this and the screen recording here shortly. It'd probably be another hour or two because I've got a couple more lessons. But I'll talk to you tomorrow, and thanks again for scheduling.
So much.
Bye now.